You're not going to believe what I found when I dug deep into how AI actually works. Every single AI tool you use daily, ChatGPT, Siri, your phone's camera, Netflix recommendations, they all use the same fundamental technology that was inspired by, wait for it, your brain. But here's the crazy part. The scientists who created this had no idea they were about to change the entire world. Let me tell you the story of how we went from studying neurons in the 1940s to creating machines that can paint like Picasso and write like Shakespeare. Picture this, it's 1943 and two scientists, a neurophysiologist named Warren McCulloch and a logician named Walter Pitts are sitting in a lab staring at brain cells under a microscope. They're thinking, what if we could recreate this in a machine? Your brain has about 86 billion neurons. Each one is like a tiny computer that receives signals, processes them, and decides whether to fire or stay quiet. McCulloch and Pitts thought, what if we make a mathematical version of this? So they created the first artificial neuron, basically a switch that could be on or off based on its inputs. Sounds simple, right? Well, this simple idea would eventually power the AI revolution we're living through right now. But there was a huge problem. These early artificial neurons couldn't learn. They were like calculators, useful, but not intelligent. Then, in 1957, a psychologist named Frank Rosenblatt had a revolutionary idea. He thought, what if these artificial neurons could actually get better at their job through practice? He created something called the perceptron, and here's the mind-blowing part. It could learn. Just like how you get better at riding a bike through practice, the perceptron could adjust its internal settings to get better at recognizing patterns. The media went absolutely crazy. The New York Times reported that the Navy expected this machine to walk, talk, see, write, reproduce itself, and be conscious of its existence. People thought we'd have robot servants by the 1970s. But then, reality hit. The perceptron had a fatal flaw. It could only solve simple problems. It couldn't even figure out something as basic as the XOR function. Two MIT scientists proved this mathematically, and funding for AI research completely dried up. This period was called the AI winter, and it lasted for decades. Here's where the story gets really interesting. The solution was hiding in plain sight the whole time. We just needed to stack these neurons in layers. Think of it like this. If one person can't solve a complex math problem, what do? You get a team of people, each handling different parts of the problem. That's exactly what multi-layer neural networks do. The first layer might detect simple things like edges in an image. The second layer combines these edges to recognize shapes. The third layer combines shapes to recognize objects, and so on. Each layer builds on the previous one, creating increasingly complex understanding. But there was still one massive problem. How do you train a network with multiple layers? How do you know which neuron in which layer made a mistake? The answer came from a breakthrough called backpropagation. Basically, it's like playing a game of telephone in reverse. When the network makes a mistake, the algorithm traces back through all the layers to figure out exactly which connections need to be adjusted. Now here's where it gets really cool. Scientists realized that different types of data need different types of network architectures. It's like having specialized tools for different jobs. For images, they created convolutional neural networks, or CNNs. These are inspired by how your visual cortex works. Just like your brain has specialized areas for detecting edges, shapes, and objects, CNNs have layers that do the same thing. This is why your phone can instantly recognize your face, or why Google Photos can find all pictures of your dog. For sequences like text or speech, they built recurrent neural networks, or RNNs. These have memory. They can remember what came before. It's like reading a book where each word makes sense because you remember the previous words. But then in 2017, Google researchers dropped a bombshell with a paper titled "Attention is All You Need." They created something called the transformer architecture. Instead of processing words one by one like RNNs, transformers look at all words at once and figure out which ones are most important for understanding the context. This is the technology behind ChatGPT, Google Translate, and basically every major language AI today. Training these networks is like teaching a toddler, but the toddler has millions of parameters to adjust. Here's how it actually works. First, you show the network thousands or millions of examples. For image recognition, you'd show it pictures of cats labeled cat and pictures of dogs labeled dog. The network makes wild guesses at first. It's basically throwing darts blindfolded. But here's the magic. Every time it gets something wrong, it adjusts itself slightly to be more likely to get it right next time. This process happens millions of times. Gradually, the network starts to recognize patterns. It learns that pointy ears and whiskers usually mean cat, while floppy ears and a wagging tail mean dog. But training neural networks is notoriously difficult. The learning rate has to be just right, too fast, and it overshoots the answer, too slow, and it takes forever. It's like trying to land a spaceship while blindfolded. That's why we have advanced techniques like the Atom Optimizer, which automatically adjusts the learning speed, and Dropout, which randomly turns off parts of the network during training to make it more robust. Now here's where things get absolutely wild. Scientists figured out how to make AI creative through something called generative adversarial networks, or GANs. Imagine two AI systems in an eternal competition. One is a forger trying to create fake paintings. The other is an art detective trying to spot the fakes. They keep getting better and better at their jobs until the forger becomes so good that even experts can't tell its creations from real art. This is how we got AI that can create photorealistic images of people who don't exist, turn your sketches into professional artwork, and even generate entirely new music styles. The implications are mind-boggling. We're not just automating calculation anymore, we're automating creativity itself. So where's all this heading? We're seeing incredible advances. Graph neural networks that can understand relationships in social media or discover new medicines. Multimodal AI that can process text, images, and sound simultaneously. Self-supervised learning, where AI teaches itself without human labels. But here's the reality check we all need to hear. With great power comes great responsibility. These systems can amplify human biases. If you train an AI on biased data, you get biased AI. They can be used to create deepfakes that spread misinformation. They consume enormous amounts of energy. The future of AI isn't just about making it more powerful. It's about making it fair, transparent, and aligned with human values. From two scientists studying brain cells in 1943 to AI that can write poetry and paint masterpieces, we've come an incredible distance. But this is just the beginning. The neural network revolution isn't happening to us, it's happening through us. Every time you use an AI tool, every time you train a model, every time you think about the ethical implications, you're part of shaping this future. What aspect of neural networks blew your mind the most? Drop a comment below. And if you want to dive deeper into any of these topics, let me know what you'd like to see next. If you want to test your skills, I've got something perfect for you. Head over to mindhustle.net and sign up for our neural network skill assessments. Click the link in the description below. The age of artificial intelligence isn't coming, it's here. And now you understand the incredible journey of how we got here.